Welcome to BioSolve IT's introductory tutorial on the Molecular Modeling and Drug Discovery program SeeSAR. This video is created as a beginner's guide meant to help new SeeSAR users learn the basic features and the usage of the application. To help users approach SeeSAR in a logical and systematic manner, the video is organized accordingly, segmented into bite-sized pieces, as we'd see in a moment. To start with, we will learn different ways to identify the exact version of SeeSAR installed on your computer. Then we will learn what modes are in SeeSAR and how to switch between different modes. Following which, we will learn multiple ways of loading protein in the PDB format into SeeSAR. Next, we learn the crucial step of ligand extraction from your protein, followed by getting hands-on with the visual components such as tables, 2D and 3D views, as well as the sequence view section in SeeSAR. This will be followed by learning to operate the system and appearance settings of the application, followed by detailed visualizations of Hyde, torsions, clashes, and your binding site. Then we'd learn how to push molecules from one mode into the other and what this actually implies. And finally, we learn how to access SeeSAR's intelligent context-dependent help system to keep you on track throughout your journey with SeeSAR. And now, without any further ado, let's jump right into it. Knowing the exact version of any software that you use is a very essential but often underrated factor from a user's perspective. In SeeSAR, identifying the exact version that you're currently working with can be done in two different and simple ways. The first and most straightforward way to identify your SeeSAR version is at the SeeSAR Start screen. At this screen, you typically encounter these three different numbers, namely the major, minor, and the patch version numbers. Together, these make up the exact version number of SeeSAR that you're working with. And from what you see on the screen right now, the SeeSAR version that I'm currently working with is 10.3.2. If by any chance you'd skipped away from this page really fast by clicking on the new project, you could still find your SeeSAR version number like so. So we first head to the top left menu, click on About SeeSAR, and now the exact information on the version number is available on this screen as well. Knowing the exact version numbers is not only helpful for you to, say, for example, cite SeeSAR in your next big publication, but also comes in really handy when you want to send in support requests for possible stumbling blocks that you might have faced in your SeeSAR journey. And just like that, we've entered the application and can now explore the different options that it has to offer for our computer-aided drug discovery journey. Obviously, there are several windows and components now visible on the screen, but first let us see one of the pivotal parts of the entire application, namely the mode switch in SeeSAR. The mode switch found over here opens upon mouse over and unveils the different modes available in the application. Within the scope of this video, we will stick to a simple definition that each mode entails its own special features and capabilities, some of which we will explore as part of this tutorial. Simply clicking on each of these icons would take us into that particular mode, so let's try that for once. Each mode is named to indicate the primary features that the mode has to offer. For example, the binding site mode contains options to define binding sites and also to search for potential binding sites from your protein when there is none already defined. The protein editor, as the name suggests, allows to perform minor edits to amino acids on your protein, but also packs a powerful feature that enables searching for proteins with similar binding sites from the PDB with respect to your query protein. The analyzer mode serves as a high-performance workbench where molecules from other modes can be brought in and analyzed in detail with a whole array of matrices to choose from and to perform high-quality structure-activity relationship study. The Inspirator mode is for all things ligand-based and fragment-based design. Options to grow fragments into binding sites and to do scaffold replacement and linking and merging different parts of molecules are executed within clicks in this mode. The molecule editor is a workbench for molecule editing, ligand design and ideation, while finally the docking mode, as the name suggests, is the place to perform super fast molecular docking runs of your library of molecules on your target protein. That was a quick gist of all the modes available within SeeSAR 10.3.2. Within the scope of this introductory video, we will primarily stay in the protein mode, using it as training wheels to familiarize ourselves with the basic navigation of SeeSAR. Now that we're already back in the proteins mode, let's explore the different ways to load proteins of the PDB format into SeeSAR. The simplest way to do this is by typing the PDB code of your protein of interest into the text field right here. And immediately you notice that SeeSAR has already pulled up the title of your PDB structure, giving you information on whether this is the correct protein that you want to load even before you move further with it. This also means that you could search for proteins from the PDB by simply entering text that describes your protein. Say I'd like to find a protein that is involved in the coagulation cascade or is a coagulation factor itself. All I do is go in and type coagulation, and even before I'm done, SeeSAR offers me a large list of proteins which contain the word coagulation in their title field. On the other hand, I could have my own PDB files or my in-house structures on my local machine that I want to load into SeeSAR. This is essentially done in 3 simple ways. And interestingly, all of these methods are already mentioned on the screen right here. And this is a pointer that most things to be done in SeeSAR are almost always given to you in crystal clear font. And let's go ahead and read this. So the first method is to directly paste your protein from the clipboard, like simple text or files that you would do. And for that, I go to a location on my computer where I've saved PDB files, copy it with a Ctrl+C, come back to SeeSAR and do a Ctrl+V on this part of the screen, and immediately the protein loads. A point to note is to make sure that your cursor is out of the text box here, else SeeSAR will start putting text into the text field where PDB entries go in. Alternatively, you could simply choose a single protein PDB file and drop it into SeeSAR, like a simple drag and drop, and essentially the protein is also loaded this way. The final method to load a protein into SeeSAR is probably also the most common one for desktop applications, is to go to the main menu here, click on the third option, load proteins, and pick a location from your desktop to load that protein into SeeSAR. In this entire process of loading a protein, you've probably all noticed a few things going on here. At the most basic level, you'd have noticed that clicking on the New button here clears the entire workspace and the entire project. But probably, and more importantly, you'd notice that SeeSAR is trying to do a bunch of pre-processing even before the protein is being loaded in. Let's have a closer look at them, shall we? And for this purpose, let's clear this protein for now and load another protein, say something that contains a drug molecule, for example, salbutamol. And then watch carefully on the steps that happen in the background as the protein's getting loaded. So there's the hydrogen bond network being computed by the PROTOS method, the binding affinity of all hetero groups to the protein is computed by the Hyde algorithm. Meanwhile, clash properties are also computed. Thus far, SeeSAR has optimized the hydrogen bond network in the protein using the PROTOS method, listed out all of the hetero groups belonging to the structure, one of which could be our ligand of interest, and also at the same time computed the binding affinity for all of these molecules contained within so that one could make an informed decision. So I could choose to select the molecule with the best binding affinity on the logarithmic scale as my ligand of interest. For the sake of emphasis, we're going to do this step one more time and make sure we note the most important points. From this list, based on the binding affinity, we choose a certain molecule by clicking the radio button and then clicking the green apply button. At this point of time, if you're not interested in extracting a ligand out of your molecule, you could always choose to hit the do not extract the ligand button and then go ahead and click on apply. Now, this molecule is extracted from your protein, and when we say extract, we do mean extract, since you could now choose to save this protein to your computer and then open it up in a text editor and then find that this molecule is not going to be a part of the protein anymore. And while the ligand got extracted, SeeSAR has done yet another helpful thing in the background for us, and that is setting up a binding site around the molecule extracted, and this binding site definition has also been notified in the notification messages panel in the right bottom corner of the screen. And you could choose to either clear it and close it. I'm gonna, for the sake of it, cancel it and leave the notification in there. And now when one mouse hovers over this part, you see the text that says messages available. I could click it open anytime and see what came in at what time. Now that we've done quite a bit of work already, let's take some time to unpack all of the features of the tables and windows that we've ended up populating here. First, let's look at the proteins table over here. Over here, we have the option to change the color of the protein by picking a color from this color palette icon. And let's go ahead and change the color of this entire protein to red now. By default, the individual chains of the protein are assigned separate colors, and by this change, we've assigned a single color red to the entire protein. If by any chance you'd like to change the name of this protein entry, simply double-clicking this field will make it editable. For my purposes, I'm fine with having this name as is. Now that we hover over this button over here, we notice that it can be expanded upon by clicking. Let's find out what it's got inside. So there we have three options. On the one hand, we could change our ligand, we could delete our protein, or we could add this protein to the protein editor mode. Right now, we don't want to do any of this, so we will let that go. However, what's important to learn from this step is that the property of being able to click, or precisely right-click and open a context menu on table entries is a common feature throughout almost all modes in SeeSAR. Moving further down, we reach the Ligands table. The most important observation here is that this table contains the estimated affinity column. Mouse hovering over this column reveals that the affinity has been predicted by the Hyde method that we mentioned earlier. It is of utmost importance to recognize that the range of the predicted affinities are in the logarithmic scale, and hence care must be taken when interpreting them or making qualitative judgments on them. Another neat feature packed in here is the presence of an annotation panel that opens up in the form of a sticky note that we've all known and used. And here, any little note about your ligand, for example, best binder, can be written and saved. And even upon closing this panel using the X over here or the cancel, I'd still notice that the annotation panel symbol has a yellow color now on it, and a mouse over actually reveals what text is contained within. Clicking on the ligand name right here has an almost immediate effect on both this 2D window, where you see the 2D structure of your molecule drawn, as well as on the 3D display. You see that the ligand has been populated here. And how we do this selection and unselection is by holding the control key and clicking on to unselect or deselect, and now you see that everything's disappeared, and you click that back on, and we can do this a couple of times to know we're sure. There. Now let's move to the 3D window where the real live action happens. Mastering the mouse and keyboard operations in the 3D window will make your life with SeeSAR exponentially more fun and productive. There are 3 essential operations that you should learn to master in 3D. The first is rotation, the next is translation, and the third is the ability to zoom in and out. Now let's learn to do each of these steps one by one. Rotation in 3D in SeeSAR works by holding the right mouse button and moving the mouse in the desired direction. So right now I'm holding on to my right mouse button and then simply moving around the screen in the desired direction to rotate my protein. Translation, which is in simpler words the ability to move your object in 3D across the screen, happens with a combination of the control key on your keyboard, your right mouse button, and then moving the mouse across the screen in the desired direction, all the while holding the control key. Zooming is done using 2 ways. On the one hand, the simpler way is to simply use your mouse scroll up and down to zoom in and out, and the second method is to use a key combination of holding both the control and shift keys, click the right mouse button, and now move the mouse forward and backwards or side to side, and then see the zoom effect come to life. Now that you've understood the basic operations in 3D, let's just learn one final trick that will take our SeeSAR game to the next level. What's the trick, you may ask? Well, the short answer is the spacebar key. Alright, so let's just say that in the process of learning to use the zoom, you've zoomed so far out with your mouse scroll wheel that you don't see the protein anymore. The logical thing to do is to scroll back using the mouse so that the protein comes back to display. But let's try something out. Let's hit the spacebar and see what happens. Well, there you go. The action that we've performed right now by hitting the spacebar key is called the focus view action. And let's try another flavor of that, this time by simply translating your protein completely almost out of the screen and then trying to hit the spacebar again. And there we've brought our protein back into the screen where we better like to have it. Now here's an important point to explain. The focus view action works on the exact component of your scene that is remains selected. Here we have our ligand selected, and that means each time I move the protein away and call for the focus view action hitting the spacebar, my ligand is brought back in an orientation where it's centered and focused on. We can try the same by deselecting the ligand now, making sure that the protein is selected, and hit the spacebar now, and the entire protein would now go on the screen in a place where it's centered and focused. So yeah, select the ligand, hit the spacebar, have a close-up and centered and focused look of the ligand, deselect, hit the protein, bam, you have the protein right in the middle of the screen. Maybe just one final point to note about the focus view option is that it can also be activated from the menu up here. So you see the utilities button over here, click on that and hit focus view, and you get the same action essentially as what this spacebar does. Now that we've essentially mastered the 3D controls in SeeSAR, let's move our focus to another set of power-packed features offered by the sequence view window down here. As the name suggests, the sequence view primarily offers different ways to approach the often useful task of looking at the sequence of your protein. The basic functionality here is to be able to simply scroll through your protein sequence, while additional functionality would be the ability to type a certain amino acid and see where it occurs in your sequence. So let's now type cysteine, CYS, and then we immediately notice that there are 20 occurrences of cysteines, and one could simply click on the arrow to jump to the next occurrence of the cysteine. And we also see that each of these occurrences are highlighted by this pink circle around. We could right click on this and either choose to hide this component in 3D or call the same focus view action that we saw and click on that, and there we get a zoomed in close-up look of this particular cysteine that we've chosen. The sequence view is actually extremely powerful in the sense that a lot of what happens in 3D is directly controlled from the sequence view. Let's see what I mean by that. So right now we see that a lot of these residues are gray, while some of them are colored red. And this is because we've currently only opted to show the residues that make up the binding site of this protein, so around this ligand. On the other hand, we would like to see all residues of the protein, and that just happens in one click by clicking over the protein name, and you immediately see that all residues are shown in their stick form. And at the same time, you could opt to simply just see the binding site alone, and we are back to the same view where only those binding site residues are shown. Click on Show Whole Protein and go back to the mode where you see all of your protein residues. So in a normal workflow, you'd like to start with just defining your binding site, and then you'd actually want to clean all of the other hetero groups besides your ligand of interest that is here, and this is done very easily. So we see the options over here. There are multiple tabs. First, that says Show and Hide Residues. We know that if we click on this once, everything disappears. Put it back on. We see there's Show Hide Ligands. Let's see what's in there. So all of the other ligand molecules shown on the side here can be entirely switched off, or alternatively you could choose to switch one or two of them off, but for now let's switch everything off. Any metals, ions in your protein structure could be switched on or off, given that they were there in the first place. And another common occurrence, crystal waters, are usually listed here. We have 2 crystal water molecules in this structure. We could go ahead and find out where they are. There is one, and the other is somewhere there. And what we could do now is to simply have them hidden, because it's kind of irrelevant for our current setup now. And that's how you hide the water molecules. Go to the next tab, you see Show Backbone Cartoons for Chains. So clearly, if we remember from the beginning of the tutorial, our chains were colored in 2 colors, indicating there were 2 chains to start with. You could decide to hide one or both of them, or show both of them to get a full picture of this protein. And with that, we've now familiarized ourselves with the powerful use of the sequence view. Now let's take a closer look at the ligand molecule that's been here. You've probably wondered all this while why there are these semi-transparent spheres surrounding all of the ligand atoms. We call these spheres Hyde coronas, and they are a direct visual reflection of the contribution of each atom to the binding affinity estimated by the Hyde method. In this way, atoms are given either green coronas indicating a positive contribution, or red coronas indicating a negative contribution to the affinity. But as we see here, we probably need a different protein with both green and red coronas. And therefore, let's use this as a chance for a quick exercise to clear this protein away. Load a new protein and extract the ligand from there. So my new PDB ID is 6MHF. SeeSAR is importing my ligands, calculating the estimated affinity, optimizing my hydrogen bond network, and I would like to pick the ligand GDP-A401 by radio selecting it. And I already have a clear distinction in the binding affinity that I see here now as compared to the previous molecule. Now we have the opportunity to see both green and red coronas, but like we did before, let's quickly clear the scene and also observe how we do that really fast. Go clean off your other ligands, no metals here, a lot of waters, remove all of that. We have 2 chains, we do not need the little green peptide chain for now. Clear that off and focus view. Now we see both green and red coronas. Large red coronas indicate that these atoms contribute poorly to the affinity, while the green ones contribute positively to the affinity. If by any chance you wish to switch off the visualization of these coronas, one could simply go over to the visualization settings here, indicated by the eye and a little gear wheel on it. Click on it and opt to switch off the Hyde coloring. Switch it back on, the spheres are on, and now they're off. We also notice there's something interesting over here, namely the torsion coloring. Switching this on immediately adds these green and orange colors to some of the rotatable bonds, and this is also SeeSAR's visual indication of the quality of the torsons that this ligand has currently sampled. So naturally, the green indicates very good torsons, oranges indicate moderately good torsons, and luckily for us, in this case, there are no red torsons, but they do occur in molecules often, especially when running molecular docking experiments. An interesting side note here at this point of time is to optimally view just your ligand molecule, we could always clear away your protein chain and also the view of your binding site residues. And now we simply have the ligand to view and explore. And as we were talking earlier, these bonds have now green torsion coloring, and here is one orange torsion. Switching this off will pull them back to their default colors. An open question at this point of time is, can we learn a little bit more about the visual depictions of the atomic contributions to binding affinity, namely the Hyde coronas? And the answer is yes, of course we can. And this now unpacks a whole array of labeling options that we have in SeeSAR that we will see one by one right now. To achieve this, we go over to the label and measure section up here, indicated by the tiny ruler and a pencil over it. The general guideline here is as follows. Each labeling method can either be clicked and activated. So I've clicked on Show Label now, and clicking on any of these atoms with the Hyde coronas opens up this panel showing the decomposition of desolvation and hydrogen bonding interaction that Hyde essentially takes into account. And another click on this eye actually now shows the neighborhood atoms that interact with this particular atom. We can switch that back on. So, as long as this Show Label button is pressed, any atom that I click on would immediately generate a label. So you see this is a threonine atom on the protein. I could click on another Hyde corona here and pull out a label for that. And if I'd like to see the contributions of the neighboring atom or the interactions with the neighboring atoms, we could click on the I here and open that up. And if there are labels that we don't like to see anymore, simply click on the X and close that off. And when you've done with all of your labeling, click on Clear All Labels to get rid of them entirely. And the second method now is to use the keyboard shortcut. And for that, I will remember the letter L, switch this button off, and now every time I hold the letter L on my keyboard, my mouse pointer changes to activate the labeling action. And when I take my hand off the L, or my finger off the L key, the labeling action is deactivated. So in practice, I could go selecting different atoms on my protein, just hit L, click label, put it on one side, another L, label, put it on the other side, do all of my comparative analysis, and just click on Clear All Labels, and that's done. Similarly, measuring distances between two atoms can be done first by activating the distance action and clicking on two atoms. So it's obvious that distances are always between atom pairs. Alternatively, just clicking on the D key on my keyboard immediately activates the distance action, as we see from the change in the mouse pointer. And then I could still go ahead selecting a couple of atoms anywhere and measuring the distances. I could close this by clicking on the X, or if I had populated the screen with too many labels, as we know, again, click on Clear All Labels. Next comes measuring angles. The letter is A, so I'm gonna hit A, and for an angle I need to select 3 atoms. That's known, so let me now select 1, 2, and 3 atoms. And I immediately have the angle between these 3 marked atoms in pink. The fourth and final interesting thing that we can measure here is the torsion. So since torsons are nothing but the angle between 2 planes, which essentially means that we have to select 4 atoms, let's hit the T key on the keyboard. You see the torsion action is activated. So let's do 1, 2, 3, and 4. And immediately you see that a symbol is drawn around this bond, indicating the torsion between these 2 planes. Let's move this to the middle of the screen. And there we have it. So labeling is fair and simple. Choose the type of label that you want to do, or measurement, and simply select the appropriate number of atoms for that type of labeling or measurement. And that is indeed a whole lot of powerful functionality packed into essentially 4 keys on the keyboard. A final little interesting feature that is essentially packed along with the torsion labeling is the fact that once we have torsion coloring on, and when we decide to label this bond, so we hit L and click on this bond, we immediately see a window popping up where the torsion angle is mentioned, and this is nothing but a placement of this particular torsion on a distribution of commonly observed torsons. So a green torsion that occurs here shows the exact place in the distribution where this torsion occurs. So in a comparative basis, let's see what this orange torsion has for us. And that occurs here in the orange part of the distribution. And switching on these eyes again highlight the 4 atoms that are actually forming these 2 planes that are part of the torsons. So with that one neat trick, we've covered the entirety of labeling, measuring, and seeing more than what meets the eye, essentially, with SeeSAR. Another very common and useful means of visualizing protein-ligand interactions is via the depiction of a binding site surface. For that, let's go over again here to the visualization settings. Click, choose the binding site surface. A single click will draw an opaque binding site around your ligand on the protein surface. At this point of time, it's probably useful to switch on the visualization of the chains of your protein so we have a better perspective of where the binding site is. There we go. A little more granularity is available here in the sense that clicking on this arrow will open up another little menu where we have a control on the transparency of the binding site so we are able to see through while at the same time visualizing the surface. And a couple of methods of coloring it. One based on lipophilicity, so that's log P based derived from Hyde, and another based on elemental colors. There we go. And we could choose to have them as opaque as well. Looking good. At this point of time, it probably is a nice idea to say, okay, let me take a nice screenshot of what I've built over here, a pretty picture. And that's very easily achieved by moving over here to the utilities. And we see that besides focus view, screenshot is another option. So I probably position my protein in a nice way that I have a perspective on where the binding site is, just as an example. Just clicking on screenshot directly would by default open up a place on my desktop where I can put my picture in, or give it a name of course, and then save it. On the other hand, we have a little more granularity available even here, in the sense that if you're saving your image for paper, you most likely want to choose paper and change, say, the DPI to something like 300, that's what most journals prefer. And on the other hand, you could choose poster and then adjust the size and dot density accordingly. But essentially, when you're done with that, you click on screenshot and that brings you to a place on your computer where you can then save your image. That said, it's often very useful to learn about the customization features that SeeSAR offers out of the box. And for this, we move over to the appearance settings over here. Clicking on the appearance settings opens a menu with various options. Firstly, we have the option to change the background color of the 3D window. So I'm not trying to change it to green or black in some cases, as people prefer. But I'm going to change this back to white for this tutorial. Next is what we have is a bunch of layout settings. So what we use now is the most common layout called the left layout. Another version called the bottom layout is available where the 3D display has the top position of the screen and all the other tables are at the bottom of the screen. If you have a multi-monitor setup, it's often useful to keep different parts of your entire screen separated, in the sense that one could have just the 3D window on one side of their monitor, on one monitor, and all of the others on the second monitor. And for that, we could use what is called the dock layout. This essentially pulls out the various components of SeeSAR, so the data tables, the sequence view, and the 2D depiction panel are available as different components, leaving the 3D screen independently for working with. And to get it back to how it was when we started, we simply click on the left layout again. SeeSAR offers two different themes. What we currently use is the dark theme, and one could also choose to use a light theme. The size of labels, as we've seen before, can be adjusted. As we quickly see here, I've marked a default a random atom for the label, and then we start at a size of 12 all the way up to 42. And finally, SeeSAR offers multiple options for people suffering from color blindness. So there's a green-red color visualization option, as well as a blue-red option. So please select the appropriate option depending on your needs. The System Settings button here opens up an essential set of settings that can be controlled by the user. Most often what is used by new users is the license button, where you want to pick your license file from your computer and load it. We remember that when we first loaded the protein inside, SeeSAR ran all of these binding affinity estimation calculations, hydrogen bond optimizations and whatnot by itself automatically. However, this can also be controlled from the system settings. This comes in very handy, especially when handling molecule sets, where loading, say, 10,000 molecules into SeeSAR at the same time and having the calculation run automatically could end up as a time-consuming process. So depending on the mode that you're in, so if you're going to load molecules from a file in a mode that supports molecules, for example, the analyzer, you'd often want to make sure that you only have those settings on for which you would like automatic calculations to take place and have the others off. So just one click would activate or deactivate it, and that's very visually seen with a green tick or a red cross. So once you've selected your custom preference from all of these automatic calculation options, do not forget to click Apply before you close this window. The final part of this video is the one where we learn how to push molecules from one mode to the other. Essentially, we're going to learn pushing this ligand molecule from the current mode, that is the protein mode, into another molecule mode, say the analyzer. As with multiple things in SeeSAR, there is more than one way to achieve this. In this case, we see a button over here that says add ligands of all proteins to a different mode. Essentially does this job. The moment we click it, we could say add molecules to analyzer, and this molecule is transported into the analyzer mode, and we land in the analyzer mode at the end of that action. This button is very useful when we loaded more than one protein and we have more than one ligand to push to the other mode. On the other hand, we could simply right click here and choose add to analyzer, and the molecule is immediately moved there. In the analyzer, you again see a bunch of calculations happening. So the affinity is calculated again, the quality of the torsion is calculated, the intramolecular clash and the intermolecular clash is also calculated. And when this happens for, say, 10,000 atoms, it is often useful to have this setting turned off when molecules are loaded, so that you save some time and you can then select only those molecules to which you want these calculations to actually happen. We've now reached the final part of the video, where we briefly see what SeeSAR's context-dependent help system can offer in your SeeSAR journey. So the context-dependent help system immediately recognizes the mode that you're in and shows help text for you to go through this mode without any problems. In the sense that if I move now to the analyzer, the help immediately changes to the analyzer mode, and to the docking, for example, changes to the docking mode. Then we come back to the protein mode, and we know that the help system recognizes where you are in the application. More than just offering this textual help, there are few other resources, link outs to a beginner's guide, link outs to our tutorial movies, online help that's offered on the website, a first start help and also a page to look at what's new with the application in terms of updates. That brings us to the end of a basic introduction and a walkthrough on the features of SeeSAR 10.3.2. We hope you've enjoyed this video, and we look forward to you trying working with SeeSAR using this video as a hands-on guide. Thank you for your attention, and goodbye.